Welcome back, folks, to Scripting for Linguists. In this episode, I'd like to answer this question. When calculating the frequency of words in many small text files, is Python faster now, at the time of recording, than it is in the past or was in the past? So in order to answer this question, we're going to look at our old friend, the Spotify podcast dataset, right, which has over 100,000 hours of audio and 1 billion transcribed words. As in the past, we're simply going to use about a third of it. So let's do that. So what I have downloaded Python 3.8.0, Python 3.9.0, Python 3.10.0, and 3.11.0. And the current version of Python at time of recording is 3.12.0. So I have those 5 versions of Python on my hard drive. And so what I have here, let's zoom in a bit here. What I have is the same script in a previous video linked to above. We looked at how to do parallel processing with Python to find frequency of words in many small text files using the same corpus. And I have that very same script here. I have done nothing at all to it. It's the exact same script from that previous video. And the main thing is we're doing parallel processing right here with a pool object. We're using the map method of that pool object. We're using 8 processes there. So this is all the same. The only difference now is we're going to be using different versions of Python. And I already did this before the video started. I did all the tests. And so let's just look at the bottom of my screen. Let me make this bigger now. Let's go up to the top of this here. So I have Python 3.8.0. And just to double check that, I have that. I asked for the version of Python. It does say 3.8.0 right there. And then I ran this same script. I did 10 iterations, 10 trials. And I, again, just print out the word types as well as the word tokens, as well as a random sampling of 6 words or 5 words there, just to make sure that I'm getting the same results with every run, with every version of Python. And we see that with 3.8, version 3.8, we get 29, 30, 29, 30, 30, 31, etc. So the mean time is 30.7, if we round up. The median time of those 10 trials is also 30.7 there. This is Python 3.8.0. The next version I looked at, as you would guess, is Python 3.9.0. And same script, nothing different, 10 iterations. And again, we get the same numbers down here just to double check that these are the same numbers. And we have about the same times, 29, 29, 30, 30, 31, 31, etc. There's a 33, 33. So the mean is 31.2 if we round up. The median is also 31.2 with Python 3.9.0. I did that with 3.10.0 right here. Same script. Just the only difference here are the Python versions. 3.10.0, ran it. And we get the same numbers, same results. I'm just double checking that. And now we get 19, 19, 19, 19, 19, 19, 20. And then we get a big old 83. That's a huge outlier. I'm wondering if it's because I ran this on my battery when I was on battery power on the bus. And I think it went into sleep mode for a couple seconds or more than a couple seconds. And so I think that's why that outlier's there. But all the others are 19 or 20. So I'm not going to look at our mean because of that big outlier. I'm going to look at our median right here. And we have a median. Let me make this even bigger for us. Our median is 19.3 if I round up. This is Python 3.10.0. I also looked at 3.11.0, version 3.11.0. Did the exact same script, 10 iterations, 10 trials, and got the same numbers, same results, good. Now we have 17.2, 17, 17, 17, all sorts of 17s. They're all 17 except this last one's 18. So our mean is 17.8 and our median is 17.8 as well. And then like I mentioned at the time of recording, the current version of Python is 3.12.0. And that's what I have here as the last run. Again, 10 iterations, same results. And we get 17, 17, 18, 18, 18, a bunch of 18s. So our mean is 18.3 and our median is 18.4. Good. So I've already put into a spreadsheet these numbers. Let me just zoom in a bit there. There are the numbers that I just read off to you. And so, yeah, we can see that with Python 3.8.0, 3.9.0, we have, let's look at the median column. Let's focus on this median column, column D. We have 30 seconds, give or take. And then starting with Python 3.10.0, we have 20 seconds or less than 20 seconds, give or take. Okay, so yeah, there was a big speed up from 3.9 to 3.10 with Python. Great. So it's like only 2/3 of the time, and this is less than 2/3 of the time that it took these versions 3.8 and 3.9 to run. So that's awesome. And I think I've noticed, on blogs and whatnot, that Python has been, the Python team has been working on making Python quicker. And that seems to be the case with this linguistic-oriented task of finding word frequencies in text files from starting with version 10. And I see online that they're going to keep trying to make Python even quicker and quicker. Here's their plan for 3.13 to keep it going, to make it even quicker. And there's even a blog post out here. I'm not sure who this person is. That 3.14, Python 3.14, which now has been released at time of recording this video, could be as quick as C++. We'll have to wait and see if that really turns out to be the case. But so to answer our question, let's back up here. When calculating the frequency of words in many small text files, is Python faster now than in the past? That is, the current version or versions versus previous versions, the past 5 versions. Yes, it is quicker in Python now than it was in the past. And this is not even looking at any of the other implementations of Python, like the PyPy. Can I get that quickly? This is an implementation of Python that's trying to be fast. It's an alternative implementation of Python. This is not looking at the Mojo language that's new. Mojo is really oriented towards AI and machine learning stuff, but it is self-branded as a superset of Python, and it's supposed to be super fast as well. I actually tried this same script using Mojo, but because Mojo doesn't yet, at time of recording, doesn't yet have a native dictionary data structure, my script in Mojo was super slow because I had to pull in, I'd use Python for several steps. Anyway, so yeah, they're making Python faster, and there are plans to make it even faster in the future. So there you go. Nice work, Python team. Thanks for joining. See you next time.